Molecular polarity. So here we're going to look at the different types of electrons. So here we have a bonding pair. This is when two electrons are shared between two nonmetals. And then we have a lone pair. This is basically two electrons that are not bonded to anything. So, bond polarity and the shape of the molecule. This is, remember when I've talked about is it symmetrical or non-symmetrical? Well, here we get into what the shapes actually look like. And this is all because of the valence shell electron pair repulsion. We typically call this Vesper model, and you're actually going to be experiencing the pleasure of creating your own Vesper models of different covalent compounds. Basically, this is the valence electrons and how they are arranged from one another to reduce the repulsion between them. So, a molecule is polar if it contains a polar bond, and remember these are the bonds that have 0.5 to 1.7 in the electronegativity difference, and they are asymmetrical or they are not symmetrical at all. So in other words, we can't do two lines of symmetry. If there is a lone pair on the central atom, it will automatically be polar. So keep that in mind. If it is a nonpolar molecule, it will contain nonpolar bonds, or in other words, the electronegativity difference will occur between 0 and 0.4, and it will have its two lines of symmetry. So let's look at some of the shapes. So this is linear, and this one is one of the easy ones because it does make a straight line. It must be non-symmetrical, and so here if we were to look at our bonds and we looked at the electronegativity difference, carbon is slightly less electronegative than oxygen. Therefore, the partial negative is on the oxygen side, partial positive is on the carbon side. We indicate that with this arrow pointing to the most electronegative element. So here we have water, and we have two lone pairs of electrons on the oxygen, and when we have this we actually get this shape and we call this bent. And since we have lone pair electrons, this end is definitely the partial negative and the hydrogens are our partial positives. Pyramidal, this is when we have, it almost looks like a pyramid, and we have this one set of lone pair electrons up on top. And here we have definitely one end that is more electronegative than the other ends. So this is our partial negative end, and the hydrogens are our partial positive ends. So what about shapes that are nonpolar? So here we have linear that is nonpolar because we have two identical atoms, both oxygen, both of the same charge. It's equal. Here's carbon dioxide, and here we have a slightly positive, partial positive in the center, but it's symmetrical. If we put a mirror here and we put a mirror here, they're the same on both sides. Tetrahedral is another example of a nonpolar. And here we could put a mirror here, and it's symmetrical, and horizontally it is symmetrical as well, so it would be a nonpolar. So here's some of our shapes and polarity. If you have one or two bonds and it's linear, it will be polar if it is not symmetrical, both vertically and horizontally, and it will be nonpolar if it is symmetrical. If it has two bonded pairs and two lone pairs, this tends to be bent, and any compound that is the shape of bent will be polar. Something that has three bonds and one lone pair, remember anytime there's a lone pair you're going to be polar, and that's our pyramidal. Here we have four bonded pairs and no lone pairs. That is a tetrahedral and it is nonpolar. The good news is in your reference packets you actually have this chart and it explains what the shapes are. So let's determine the molecular polarity and shape. So here's carbon tetrachloride, and here, would this be polar or nonpolar? Well, here it is symmetrical vertically and it is symmetrical horizontally, and there are four bonds, so this would be considered a nonpolar because it's symmetrical, and it is tetrahedral because it has four bonds. What about H2S? This here is polar because if we look horizontally, it is not symmetrical. This is considered bent. So check your understanding. If you have trouble with this, ask in class.